In this video, we're going to be looking at key features of two different graphs. We're going to be looking at the graphs of x cubed and also the graph of the absolute value of x. So what we are working on is building a library of parent graphs. We've already done these first 5. We have these 3 algebraic graphs and also these 2 trigonometric graphs. And we are working on adding more graphs to that library. What happens is you memorize these basic shapes and then they all transform the same way. So when we get ready to do transformations, we're going to be able to transform all of our different shapes because they all transform in the same manner. The one we're going to work on first is x to the third. Okay, let's see if we can get a graph for x to the third. So if I think about graphing that, I'm going to do a table of values in my head, and I'm going to start here at 0. So 0 substituting in for x, 0 to the third is 0. Put a dot right there. All right, and if I pick another couple points here on the right, let's do 1. You can see 1 would be right here in between 0 and 2. So 1 to the third, 1 times 1 times 1 is 1. That's going to be here. All right, and now let's do 2. 2 to the third, 2 times 2 times 2 is 8. Well, that's already so big, it's almost off my screen. Now this half of it looks sort of like a parabola, the way that it's shaped there, but it's a lot thinner than a parabola. It's actually going up more quickly than a parabola would. In fact, the higher this exponent is, the steeper this is going to be, the more quickly it's going to grow. So let's connect the right-hand side. We'll have an arrow there. It's going on and on forever to the right, on and on forever up. All right, let's see what happens when I graph some negative values. So I put -1 in there for x, -1 to the third, -1 times -1 times -1 is -1. All right, now let's do -2. Substitute that in for x, -2 times -2 times -2, well that's -8. So again, it's already so large that it's off my screen. So if I connect the dots this way, there's our parent graph for x to the third. And you can see that when the values that I cube are positive, my graph is positive. And when the values that I cube are negative, my graph is negative. All right, let's think about domain and range. So domain, remember, is all the possible x values. And these arrows tell me this one means it's going on and on forever left and down. This one means it's going on and on forever right and up. Domain is with x, so domain I want to use the idea of left and right. So all the way to the left on this one, all the way to the right on this one, no jumps, no gaps. So therefore the domain is -infinity to +infinity, or I could use my all real numbers symbol. Okay, let's look at range. Range, you remember, is bottom to top, always smallest to biggest. So this tells me, we already said, it's going on and on forever down. And this one, we already said, on and on forever up. So my range is going to be the same, -infinity to +infinity. And again, I could use that all real number symbol if I want. Okay, x-intercept. So the x-intercept, remember we said in our other video, there are some synonyms for x-intercept. They're also called roots. They're also called solutions. It's also the zeros. So when I set this equal to 0, when I put 0 right here for y, and I find the solutions, that's going to give me the x-intercept. So let's do that. Let's put 0 in place of y. And I'm going to take the cube root of both sides. Opposite of cube is cube root. So x equals 0. So what this tells me is when my y value is 0, my x value is 0 also. So that means that both my x-intercept and my y-intercept for the x cubed graph are going to be the origin. And you can see right there that it does cross both the x and the y axes at the origin. Okay, let's look at positive intervals. So positive, you remember, means above the x-axis. So right here is where it's positive, and I'm going to put an arrow right there. No technology can give me those arrows. And then negative. Negative means it's below the x-axis. So my negative interval is here. And again, I'm going to put that arrow because my technology cannot do that for me. Okay, so intervals where this one is positive. Let's see, intervals go left to right, and intervals always use x values. So as I move from left to right, you can see that it begins being positive here. That's where it crosses the x-axis. I need to use my x-intercept to find this point, which we said was 0, 0. And it continues positive on and on forever. So that means my interval for positive is going to be from 0 to positive infinity. Remember, 0 is not included because the y value of 0 is 0, which is not a positive number. Okay, let's do intervals for negative. All right, just like with positive, I need to write my interval from left to right, and I'm only going to use x values. So look down here, that arrow, remember we said before, that means on and on forever to the left. So I'm going to start off at negative infinity, and it continues being negative. It stays below the x-axis until it gets to 0. Okay, so at 0, should I put a parentheses or a bracket? Well, I'm going to put a parentheses because 0 is not included. The y value at 0 is 0, right? And 0 is not positive or negative. So I do not include 0 in the negative interval, and I do not include 0 in the positive interval either. All right, how about increasing and decreasing? So let's look at increasing. Increasing, you remember, means going up. And I always read my graph from left to right. So some of y'all were trying to read from the middle out, and I don't want to do that. I want to start over here on the left and then follow the graph to the right. So if I look over here on the left, I remember that I have an arrow right there, and it is going up. So I'm going to follow that curve, going up, going up, going up, and I can see that it's going to be forever going up. So my interval where it is increasing from left to right, always my x values, negative infinity, positive infinity. So what does that mean for my intervals where it is decreasing? Where is this one going down? Well, it's not going down anywhere, so I'm going to write none, or I might write there are not any intervals, or I might write it is not increasing anywhere, but something that tells me, I'm sorry, it's not decreasing anywhere. I just need to write something that tells me I know the answer to that question. Don't leave it blank just because there is no interval where it is decreasing. Okay, so let's now look at our other function that we want to consider, and that is the function y equals absolute value of x. Okay, let's do just like we did for x cubed. Let's substitute in some values. So 0. When I put 0, the absolute value of 0, you remember that absolute value measures distance away from 0. 0 is no units away from 0. It's right there on 0, so I'm going to put a dot. All right, and then if I go to 1, substituting a 1 right there for x, well, 1 is 1 unit away from 0, so I'm going to have a dot at 1, 1. And then 2 is 2 units away from 0, so I'll have a dot at 2, 2. And I'll have a dot at 3, 3 for the same reason. And you can see that I'm going to have a nice straight line right here going on and on forever up and to the right. But it is a straight line. These connect in a linear manner. Okay, let's see what happens on the left-hand side. So when I substitute in negative 1 for x, okay, well, remember, absolute value measures distance away from 0. Negative 1 is 1 unit away from 0. It's just that it's 1 unit in the negative direction. So I'm going to get negative 1, 1. And then same thing, negative 2 is 2 units away from 0. It's just that it's in a negative direction. Negative 3 is 3 units away from 0. Negative 4 is 4 units away from 0. And you can see, like just like before, that's making a nice line. So it's linear to the right and it's linear to the left. And it makes a V shape. The parabola made a U shape, but the absolute value graph makes a V shape. Okay, so let's look at our key features. So domain. Domain is left to right. Always read from left to right. So the furthest at the left that this one goes, that arrow tells me it's going to negative infinity. Remember, don't look at the fact that it's going up. Look at the fact that it's going to the left. So negative infinity. And this arrow tells me it's going on and on forever to the right. So that's going to be positive infinity. All real numbers is fine as well if you want to write that. Okay, so let's do range. Range is bottom to top. The lowest that this graph goes, right there at 0. And the highest that this graph goes, well, it's going on and on forever up right here and also right here, so it's going to go to infinity. All right, so at 0, should I include 0 in the range? Does it actually touch 0, or should I not include 0? Well, I should include 0 because it actually touches 0. The distance from 0 that 0 is 0, right? Lots of zeros in that sentence. So 0 is included. I'm going to put a square bracket, but infinity is not because you can never actually reach infinity. And I'm not going to use my all real numbers symbol for this one because it is not the negatives. It's only the positives on the range, or the positives and 0. Okay, x-intercept. So just like before, I'm going to find the solution when I set y equal to 0. So I'm going to put 0 in place of y, and then I'm going to solve that. So the absolute value of x is 0. That's asking me what number is 0 units away from 0. Well, the answer to that question is 0. There's only one number that is 0 units away from 0, and that is 0 itself. So just like before, both my x-intercept and my y-intercept will be the origin. So I'm going to have the point 0, 0 for both of those. All right, how about intervals of positive? Remember, for positive, we look at where this one is above the x-axis, and I always read my graph from left to right. So if I color blue everywhere that this one is above the x-axis, all right, I'm going to be on and on forever in both directions except for one place. Right there, actually at 0, this graph is not positive. That graph is actually equal to 0. So when you do this, when you write your interval for positive, it's positive on the left-hand side of 0, and it's positive on the right-hand side of 0. So we're going to take away the value of 0. Do you see it's not included here or here? That's a 0, not a 6. It's not included in either place because at 0, the y value is 0. Okay, how about where it's negative? Where is this one negative? Well, it's not negative anywhere. It's not below the x-axis at all. So there are no intervals where this one is negative. All right, let's look at our last two features. So intervals of increasing and decreasing. Let's do increasing first. Remember, you always read the graph from left to right. Don't read from the center out. So increasing means going up, and here is where it's increasing right here. It's going down, and then it's going up. So it's increasing on this side. Add that arrow in there to show it goes on and on forever. And then decreasing, well, decreasing means it's going down. So it's decreasing right here as I go to the left. Okay, so let's write our intervals for that. My interval for increasing is going to be 0 to infinity. It starts increasing right here at the minimum value. Remember, we looked at that before. You need the minimum and the maximum for this. In this case, we have a minimum value right here. And it goes on and on forever up and to the right. So I'm going to be not included at infinity. I'm also going to be not included at 0 because actually at 0, it's changing from decreasing to increasing. It's not doing either one actually at 0. Okay, let's do my interval for decreasing. So left to right, smallest to biggest, it's going to start decreasing at negative infinity. Remember, this arrow is pointing left. Don't look at the fact that it's going up. Look at the fact that it's going left. So negative infinity up through 0. Okay, based on what we said before about increasing, should I put a parentheses or a bracket on 0? Well, I'm going to put a parentheses because it's not included. At 0, it is neither increasing nor decreasing. It is changing from one to the other. That's our minimum value. All right, so now we look at our parent graphs. We now have 1, 2, 3, 4, 5 algebraic graphs, and we have 2 trigonometric graphs. So we have some more graphs that we need to continue adding, but so far in our library, we have 7 graphs.